Okay, so trying to help a little bit with homework number 2. Remember, we do the homework and submit it to the Blackboard. Formal charge was asked. So what is a formal charge? For formal charge, the easiest thing is to draw a circle around the element and count the number of electrons inside the circle. Oh, sorry. So now the first one, oxygen, if you count, has 1, 2, 3, 4, 5, 6, 7. If you look at periodic table, oxygen really has only 6, so we have extra one. So that makes the formal charge for this oxygen negative. I like to put the negative right on top of the element, not in the bracket. Now if you have one negative, we show it as negative. We don't show it as -1 or 1 negative. Just show it as negative. Now nitrogen here, if I count the number of electrons within the circle, we have 1, 2, 3, 4, not 5, should have 5. So it lost one electron. So the formal charge for nitrogen would be plus. Again, plus, not +1 or 1 plus. We only use it as a plus. Look at the oxygen here. Oxygen has 1, 2, 3, 4, 5. Should have 6, but it has 5. Should have 6, it has 5. So lost one electron. So that would be plus. This nitrogen here has 1, 2, 3, 4, similar to one on the top. So it would be plus. It's very easy. Just all you have to do is to draw a circle, count the number of electrons, and see what they are in the periodic table. So oxygen should be 6, nitrogen should be 5, etc., etc. Just subtracting or adding. So this is one other question for this homework here, homework number 2. Now, also, we need to look at the structure based on the formal charge, based on everything else. We have to decide if the atoms have electrons or not. That's very critical when we get to mechanism. So if I redraw this vitamin C, and then I made a little zigzag from it. I left this hydrogen on. And there's a reason for it because there's a stereochemistry involved with this hydrogen. But I took the other hydrogen, this hydrogen, and that was it. I'm not showing on the zigzag structure. So we go around this mostly oxygen, and this oxygen don't have any charges. None of them have any charges. So they all should have 6 electrons. So again, if I draw a circle here, 1, 2, 3, 4, 5, 6. Same thing here, 1, 2, 3, 4, 5, 6. Same thing here, 1, 2, 3, 4, 5, 6. Same thing here, 1, 2, 3, 4, 5, 6. Same thing here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's if I want to show all the lone pair on the oxygen. Question on the resonance structure. We talk about that, did some homework, read the book, read the textbook, read the slides. So we start with, this is a nitrobenzene. So nitrobenzene basically has nitrogen, a double bond O, single bond O. So this oxygen is negative. I didn't show the electrons here. And nitrogen, because it has 4 bonds, is positive. So look at now we're going to draw the resonance structure. We have a pi bond here next to a positive charge. So if I draw an arrow from here to here, make a double bond between the carbon and nitrogen, but nitrogen cannot have 10 electrons. So the double bond between the nitrogen and oxygen this double bond here has to go away to make room. So now we're going to have a nitrogen single oxygen. Now that oxygen has 7 electrons, so it would be negative. This oxygen was already negative. Nitrogen stays positive because it has 4 bonds. Now once we move this electron from here to here, this has a hydrogen here. Remember, we don't show the hydrogen. So if I redraw the hydrogen here, so this carbon here would be positive. Again, we can continue the resonance structure. We continue the resonance structure. You have a pi bond next to the positive. So I can draw the bond here, a double bond, move the double bond there. If I move the double bond here, this carbon here would be positive. Now we have another pi bond here next to a positive charge. So I can make a new double bond here, new double bond here. By moving the electron from here to here, make a double bond, this carbon now would be positive. This carbon would be positive. So this is another resonance structure. Now from here to here, if you look at it, the double bond is back here. So how did that happen? And there's a new double bond between the O and nitrogen. So we can envision that we move this electron over here. So a double bond forms here, and this pi bond here between nitrogen and carbon goes back here to make the double bond. So this basically what we learn later on. We get our benzene group back, which is very stable, more aromatic compound. And we have all the resonance structure that nitrobenzene can have. So there is another question on that at the so far so good. Then there's a